Hello, this is Yelin, and I will explain the homework for question 1. We're given that the gx is a function. It's the relation between x and y. So from the question, we draw the gx. Gx is like this. So there are several special points of y. It's gx also is y. So first point is when y equals to 1. When y equals to 1, and the probability when y equals to 1 is the probability of x less than or equal to 0. And we also know that is capital F fx is 0. And the probability of y equals to 0 means that the probability of x greater than or equal to 0 and less than or equal to 1. So it's capital X1 minus capital X of 0. And the third special point is the probability of y equals to minus 1. And when y equals to minus 1, we know that that is equals to the probability of x greater than or equal to 2. And we could rewrite it like 1 minus the probability of x less than or equal to 2. So it's 1 minus capital X capital fx2. And we also know when y between -1 and 0, the probability of y less than or equal to capital Y less than or equal to y equals to we could rewrite it like in this form, because in this part y equals to minus y plus 1, and we rewrite it, we could get the probability when y less than or equal to capital Y less than or equal to y equals to 1 minus capital Fx of 1 minus y is equals to capital Fy of y in when y greater than -1 less than 0. So we got so in other range y equals to the probability equals to 0. So we could sum this and write the PDF of y. So when y equals to -1 is 1 minus capital Fx of 2 times delta y plus 1. And when y greater than -1 less than 0 is equal to fx of 1 minus y when y equals to 0. And we got is capital Fx of 1 minus capital Fx of 0 times delta y. And when y equals to 1 is capital Fx of 0 times delta 1 y minus 1. And in other points or otherwise Fy of y equals to 0. So we integrate this and we got the CDF, the capital Fy of y. But we need to plot this two functions. So in order to explain this clearly, I draw the picture. I draw it. When we know that when y equals to -y is a impulse, and it's equals to 1 minus capital F of fx of 2. And when y equals to 0, and it's like this, when y equals to 1, the area of this impulse is capital Fx of 0. But when y greater than minus 1 less than 1 is equals to fx of 1 minus y, we could get this shape, get this curve by using fx of x. We're given this, and we could get fx of minus y or minus x is whatever is just the variable, and we got this form, and we move this this curve to one step, and we got this. So we also know that in this function, we just need y greater than 1 less than 0. So we just need this curve, and we put it here. So we got the PDF of y. But in integral, we also want to draw the CDF of y. So we know that when y greater than 1 is 1, when y less than or equal to minus 1 is 0. But we also know there's an impulse. Impulse means jump. Yeah, so we could draw this like, because when y equals to 1, there's an impulse, and the area of this impulse is fx of 0. So we draw this, and we also know that when y greater than 0 less than 1, the probability is 0. So there's a horizontal line, and when y equals to 0, and it's also a jump, so we draw it like this, and the length of this is a capital F of fx of 1 minus capital Fx of 0. And we know that when y equals to minus 1, it's also a jump, and it's equals to this. So, but we need to draw when y greater than minus 1 less than 0. So we could also use capital F of x or y, and we're given. We could draw it like this. Because we're given it, and when we could also draw the minus y when it's inverse by this. We got this, and we also need to move one step on the right side, and we got this, and we need to use 1 minus this function, so we got this curve. And we also know that y greater than minus 1 less than 0, so we just need this part on this. Finally, we got this two graph, and that's it. Thank you.